Greetings, children. I know I usually make animations, but I had an idea for this at 5 AM and I thought, it couldn't be that hard. This video covers how Terraria saves its player data into files, or more specifically, how all the items are saved into a string of binary data. When I started this project, I expected to be able to just open the file in the hex editor, a program that lets you see a file's binary data, and see straight the values in binary. However, when you actually open any player file, you see what pretty much amounts to gibberish. There's a seemingly random spread of bytes and a text column is full of unreadable junk. Since I wasn't going to trial and error my way through this hell, I went online and found some kindly open source code, namely Terraria, an inventory editor compatible with 1.4.1. After several hours of attempting to read C#, I found my answer in this line: Rigendale. Rigendale is an encryption algorithm. If you've never heard of it, it's pretty much AES, the standard encryption algorithm used in pretty much everything. If you're connected to a website with HTTPS, you're using AES. Terraria player files use AES, specifically with a 128-bit key, or AES 128. This method of encryption is still pretty much unbreakable. Why are the files encrypted? No clue, and pointless really. Terraria is an offline game, and files can be transferred between copies, so the key must be stored in the program itself. Decompiling the program would net the key easily. As a matter of fact, here's the actual key, a 128 length pile of bits. Using these bits as the key and the IV lets us decrypt the files. Opening up our new decrypted file and comparing it to our old file gives us a night and day difference. Right off the bat, we can see that data in the form of the player's name has emerged, confirming that the decryption has actually worked. Now that that's out of the way, let's discuss how the actual data is stored. Terraria players have a lot of attributes: name, game mode, HP and mana stats, clothing, gender, color, hairstyle, playtime, quests, all 5 inventory, buffs, coins, ammo, equipment, equipped items, research, and spawn points. Probably more than you expected, and definitely more than I did. Despite this, it's actually quite simple. Though most of these stats have been around since the beginning, lots of these were added later on. This means that different versions player files are formatted differently. The game needs to know what version the current file is encoded in. Thus, the very first 2 bytes at the very top of the file tell the game what version the file is for. The hex editor displays the binary data as hexadecimal split into bytes, since pretty much everything works at the byte level, not bits. If you're wondering what hexadecimal is, pause here and read this short snippet. Anyways, we can convert these 2 bytes into a number, little endian, to get the version code. If you're wondering what endianness is, pause here and read this other short snippet. The version code for the latest version is 234, or 1.4.1.x. The rest of the video will concern the latest version and onwards, since I can't be bothered to look into how files work historically. The next part is read logic. Literally, offsets 4 to A just spell out read logic. I don't know what purpose this serves, but it's there. Anyways, let's start with the simple values, just a single value that corresponds to one thing. Our first piece of actual data is the player's name, which starts on offset 19. We already saw it right after the decryption. The byte right before offset 18 expresses how long the player's name is, letting the program know how far ahead to read. The name is stored as plain 8-bit text for however many bytes it is long. The byte right after the name stores the game mode, whether the character is softcore, medium core, hardcore, or journey. From now on, any further data locations can't be based off the start of the file. The length of the name's data is variable. Data from a character with an 8-letter name will start 2 bytes earlier than one with a 10-letter name. 44 bytes in plus the player's name is the HP and mana data, totaling 16 bytes. Splitting these 16 bytes into 4 sections, we get 4 32-bit integers, encoded in a little endian, of the HP, max HP, mana, and max mana respectively. 8 of the 16 bytes are never actually used in vanilla gameplay, since just 2 bytes can store numbers up to 65,536. Next comes everything you set in the character customization screen. The player's gender and clothes style are actually combined into one number, since their clothes are tied to your gender. This 1 byte value is found right before the start of the HP and mana data. Here's a cheat sheet for what value means what. 8 bytes for the gender and clothes code, and 9 before the HP data is your hairstyle ID, also stored as just 1 byte. 68 plus the name length bytes, and we find 21 bytes of data to store 7 colors for each of the color options in the character select screen. This is common knowledge, but a color is stored as 3 bytes, 1 for red, green, and blue. Once you've created your player, you gotta play it, and Terraria time shames you with the counter on the side. You can find this data right after the game mode and right before the hairstyle ID. It's an 8-byte little endian value, our first 64-bit value. This value stores how many 1/10,000,000th of a second have passed. Does it need to be this precise? No, but alas. Despite effectively wasting 7 orders of magnitude and pointless precision, this long 64-bit value will continue to count time dutifully for another 50,000 years. There are two more simple values left, things that aren't lists: fishing quests and what TerraSaver, another inventory editor, calls bartender quests. Unlike all the previous values, which are all found in the first 100 or so bytes, these values are usually at the end of a file. Around the 2,500 bytes down into the file, you'll find this chunk of 16 bytes which all hold a value FF, or 255 in decimal. Since it's so large, I'll call it the Great Terminator. Importantly, it's a new reference point. Counting the bytes relative to the name data doesn't work anymore, since something in between also has a variable length. I'll get back to that later. Anyways, 4 bytes before the Great Terminator, there's a 4-byte 32-bit little endian value that concerns how many fishing quests you have completed. There's another similar value that stores the bartender quests, 64 bytes after the Great Terminator. Alright, we're done with the simple values. Now onto the inventories, or actually 8 of them. First, a look at how items are stored. There are 2 types of items, inventory items and regular items. What's the difference? Inventory items can be favorited, and thus take up an extra byte of space. Items in, say, a piggy bank can't be favorited. An inventory item is saved as 10 bytes. Bytes 0 to 1 being the item ID, little endian, 4 to 5 the quantity, little endian as well, and byte 8 the prefix, and byte 9 whether the item is favorited or not. 4 of the 10 bytes are wasted. And no, I have reason to believe that they are in fact not 32-bit values. I'll get back to that later also. Byte 9 is just a boolean, set to 1 if favorited, and 0 if not. Both the item and the prefix can be grabbed using an ID number instead of spelling out the whole name. This makes storing the item much more space efficient, and thus is used on most programs. A regular item is stored similarly, except it's only 9 bytes because favoriting is impossible. Our inventory items start 239 plus the name lengths bytes down. 50 of these 10-byte sections are lined up, totaling 500 bytes, 1 for each slot of the inventory. And no, there's no 51st slot for the trash. The trash isn't saved. It's not worth saving. That means there's a whole 200 wasted bytes in the whole array. And if to store this 14 by 14 bitmap image, that's actually a whole 40% of the array itself wasted. Directly after are coins and ammo, which are stored identically per item to the inventory, 8 times 10 bytes or 80 bytes. Nothing too extraordinary about that. Now after both the coins and the inventory slots comes our equipment, not to be confused with equipped items. What's interesting about these 10 items is that they're actually stored as only 5 bytes each. How? They stopped wasting space. Ingenious, I know. Since the ID and quantity are only stored as 2 bytes here, I have reason to believe they're only stored as 2 bytes everywhere else, thus confirming that those bytes were indeed just wasted space. These 10 equipment items are stored as just 50 bytes. Hooray for efficiency, right? Well, not really. There shouldn't be a need to store the quantity or prefix, decreasing the needed data to 2 bytes per item. In fact, the quantity is always stored as 0. Waste. After these better 50 bytes, we head into the auxiliary inventories and back into inefficiency. Auxiliary items are stored as 9 bytes each using the same inefficient coding as the inventory, minus favoriting. The piggy bank, safe, defender's forge, and void bag are 40 items of 9 bytes, making 360 bytes each and 1,440 total, stacked end to end into one block in their respective order. Again, nothing extraordinary. Lastly, our 8th inventory, equipped items, or armor, accessories, vanity, and their dyes. These items are actually stored into 150 bytes preceding the inventory, starting 89 plus the name's length bytes in, just like their equipment counterparts are stored efficiently in 5 bytes. However, just like before, quantity in equipped items isn't used, and prefixes are only needed in 14 of the 30 slots that hold accessories. Totaling up every wasted byte, we get 978 wasted bytes. For a non-journey character with no spawn points, that's over 37% of the character's data. Oh yeah, spawn points. Remember a few minutes ago when I said that the Great Terminator was a new reference point? That's needed because of spawn points. 2,480 plus a name's length bytes down into a file, we arrive at where the spawn points are located. Spawn points work a bit differently than everything else in the player file. A 4-byte wall of FF bytes is a Terminator telling you when the spawn points end. The game will keep looking for more spawn points until it finds a Terminator, which tells the game that there are no more spawn points. A spawn point consists of 4 values: the X position, Y position, world ID, and world name. I don't know where the world ID comes from or how it's generated, but rest assured that there's a world ID and it needs to be there. The X, Y, and world ID are stored as little endian 32-bit numbers, as the first 12 bytes of any given section respectively. They're just numbers after all. However, the world name is a string. It's stored similarly to the player name. The 13th byte right before tells the game how long the name is, and the name comes right after. That does it for a single section. As many sections are lined up back to back as needed until the Terminator is found. According to TerraSaver, you can only have up to 200 spawn points, but I see there being a theoretically infinite amount of spawn point storage potential. Buffs. These start 2,309 plus the player's name's bytes down into the file. There is space for 22 buffs. Buffs are stored as 8 bytes. Bytes 0, 1, 2, and 3 store the buff ID as a little endian 32-bit number. And bytes 4, 5, 6, and 7 store the duration in ticks as a 32-bit little endian number. 22 buffs total 176 bytes are lined up back to back to store all the buffs. So, name, game mode, HP, mana stats, clothing, gender, color, hairstyle, playtime, quests, and all 8 inventories and spawn points. That covers everything for a non-journey character. But of course, journey characters are special and have the power of research, something else the file needs to store. Being one of the newest features of the game, research is found at the very end of the file. 81 bytes after the Great Terminator, we find the start of the research data. It doesn't take a genius to notice something is different. Keep your eye in the text column. Let's ignore the specifics for now and just take a look at how it's stored. This is a max research character. The items just keep on going and going and going. In fact, a character with maximum research is 93 kilobytes, while a character with none is only 3. We've established before that every item in the game is an ID number. Any item can be represented in just 2 bytes. However, research stores them in their internal, human-readable name, instead of their small numerical ID, which, surprise, surprise, is insanely inefficient. If you thought wasting 2 to 4 bytes per item was bad, that's nothing to this kind of waste. Why? Why would you do it like this? Anyways, 81 bytes after the Great Terminator, you will find a 32-bit little endian number that expresses how many items have been researched. Directly after, the researched items sections begin. Since we're storing text, we'll use the same system as the spawn points, world names, and the player names. The first byte of each section expresses how long the succeeding text is. The text is the name. Save and drill. After that, another 32-bit little endian number expresses the quantity of item researched, and that wraps the section. A fully researched character has 5,014 researched items. All 5,014 of those items take up a whopping 91,981 bytes. That's an average of over 18 bytes per item. However, it only stores an item and a quantity. We can do the same with just 4 bytes, 2 for ID and 2 for quantity. 5,014 of our new efficient research items total 20,056 bytes, just over 20% of what it was before. Come on, read logic. You can do better. Now that's a wraps for everything. Well, almost. Well, that was a ton of information. That does it for the video. I'm not going to animate decoding a player file here yet. If you want to see it, consider trying it yourself manually or writing a program to do it. My own program that I use to test my claims will be in the description. Go do more important things.